Hello dear friends, welcome to Gate Academy Global. So before starting today's session or today's video, I would like to take the concurrence or the feedback from each one of you regarding the quality of video as well as audio. Is it perfect or not? If it is perfect, just write perfect over the live chat and then we shall start our today's session. So I would just be waiting for your feedback over the live chat, and if the quality of audio as well as video is perfect, you can just write perfect over the live chat. Okay. Anyways, the agenda behind the series on engineering mathematics which we are going to start from today onwards is very precise and clear. The person or the student who have followed me in my crash course of engineering mathematics on our global channel, there I could not spend much amount of time over the vector calculus as well as over the probability distribution, density, random variable, random process. But those two topics are utterly important topics if you sit into the gate or even if you sit into the EAC, specifically electrical, and in so many different branch, specifically communication as well as signaling system. So what I thought to plan a series over this two specific topic. At very beginning, I would be discussing about the vector calculus. I would be discussing about the each and individual details, each and individual tools in the great detail. Perfect, no? Each and individual tools in the great detail. I know many of us know how to perform the divergence, how to perform the curl, how to perform the gradient. They also know if a certain vector quantity is being given, they know how to perform the surface integration, line integration, closed surface integration, closed line integration, but most of us do not exactly know the physical significance of a line integration. Even the line integration can be subdivided in the two part, vector line integration and scalar line integration. Similarly, the student are not well aware with the surface integration. Even the surface integration can be bifurcated into the two parts. First is going to be vector surface integration, scalar surface integration. And I know end of the day, a student get the answer by solving a certain by-hearted process, but exactly they do not exactly know what they have done with a certain problem. So anyways, the agenda behind this series is to just give a strength towards the two important topics within the engineering mathematics. Not only in the engineering mathematics, even those two topics are utterly important in your core technical subjects. Yes. So from today onwards, I would be focusing over the vector calculus. Yes. So it's gonna be my lecture number 1. And as the series begins from here, so that means in next 20 to 25 days, you are going to be engaged along with me, and probably the two topics I am going to cover in the great detail. The first is going to be vector calculus, and the second is going to be the topic where most of the student used to scratch their brain. That is nothing but the random variable, random process, probability distribution, probability density function, and end of the day you would be much thorough with the each and individual conceptual details, with each and individual tools. Not only that, even you will start feeling their practical usage. End of the day, my agenda would be over. Agreed? So now the next thing comes in my answer. This series which you have planned is going to cater which are the branch. This videos which are supposed to come in daily basis, it's going to cater all of the branches. Either you are from electrical, either you are from electronics, either you are from instrumentation, mechanical, civil, chemical, production, for all of the branches where the vector calculus do come into the picture. Yes, it is important for all of the branches. As the videos are supposed to come in our global channel, that means yes, the mode of communication would be in English. But I don't find the student who are from the northern part of the India would find this series so difficult. Yes, because most of the technical communication used to be taken place in English. Here I would be using the 100% English. Probably I would be well communicating, and probably you guys would be well understanding. So you guys would not have any problem from here onwards. Sir, I am from EC. Okay. So that's good now. That's good. So anyways, let me go into the working board. And let me brief how this complete series will move on. Yes, you should have a little bit glimpse, sir, how the complete series would move on. Anyways, at very beginning, let me share the plan of this series. Probably we are going to have daily basis classes for next 20 to 20 days series. So we are going to have daily basis classes for next 20 to 25 days. 25 days. Yes, such that you guys would be well acquainted with my schedule and you would be able to manage in the proper way. Yes, that is why the schedule is already been made. That's the first thing. That's the first thing. The second thing comes, how much time we are going to spend together in daily basis. Approximately 1 hour we are going to spend in daily basis. Yes, that means probably my class would last maybe 1 hour, sometime 50 minutes, sometime 1 hour 10 minutes. More or less on average I would be engaging you guys around 1 hour. Around 1 hour. Agreed? That's the first thing. Your visualization is amazing. Thank you dear. Thanks. Sir, please cover all topics. We'll see. We'll see. Yes. Third. What are the topics which we have planned to take specifically in this series of mathematics videos? So basically I have planned to take the 2 different topics. The first is going to be vector calculus. And probably we are going to spend more than 15 hours only over the vector calculus. Now many of the students would ask, sir, why this much amount of time is required to spend over the vector calculus? My dear friends, you know the different tools, you know how to perform the different tools like curl, gradient, divergence, but exactly you do not know their practical significance. And once you do not know its practical significance, that is why you suffer a lot once you go into the practical subject which are mounted over the vector calculus, like electromagnetic field theory, which is there within the electrical, electronics as well as instrumentation. That is why I have exclusively planned the series over the vector calculus. We are going to spend a plenty amount of time over the vector calculus. End of the day, really you would have a handy understanding about the each and individual tools and their practical aspects. Yes, once the vector calculus is getting over, the next topic which I have planned to take, and that's nothing but the random variable and random process. Random variable and random process. Random process, where I would be discussing about all of the important distributions. Either it is continuous random variable, either it's a discrete random variable, where I would be talking about the binomial distribution, Poisson distribution, normal distribution, uniform distribution, exponent distribution. Not only that, that used to happen everywhere. But what's the difference between rest of the people and the series which I have planned? End of the day, you would have a practical understanding about the random variable and their distributions. That is why this series has been planned for. So may I know what are the 2 different topics which we are going to cover on? That's nothing but the vector calculus, and the second is going to be random variable and random process. Yes, once I say vector calculus, the each and individual topics would be thoroughly covered. At very beginning I would start with the coordinate system, and specifically I would not be restricting myself towards the Cartesian coordinate system. Even we will have a little bit glimpse over the cylindrical as well as spherical coordinate system, because once in a while the problem do come from that segment also. Yes, that's the first thing. Once we are done with the coordinate system, we'll move ahead and we'll try to understand the different mathematical operators like vector addition, like vector multiplication. The vector multiplication used to have the 2 category, dot multiplication and cross multiplication. If I would ask one thing, what is the practical significance of the dot multiplication and cross multiplication? Why the invention of the dot as well as cross multiplication has been taken place? Would you have any answer? No. But once you are done with my vector calculus, definitely you will have answer for that. Agreed? What I am saying? Why the sine theta have come over here across the cross multiplication? Why the cos theta have come across the dot multiplication? Why the cross multiplication leads a vector quantity? What is that vector quantity, and why the vector quantity is normal over the 2 vector? There are several doubts. Mostly the student used to just by heart. What they would say? Sir, A cross B is equals to mod of A, mod of B, sine of theta, A n cap. But exactly they are not able to understand from where the concept of cross product have come into the picture, and from where the concept of dot product have come into the picture. Next thing, even the student used to say, sir, vector addition is quite simple. The component in the direction of x, in the direction of y, in the direction of z would be added. But end of the day, if you're not practically understanding what does that practical meaning of the vector addition, basically you are going to trap a lot in your practical subjects. So each and individual tools will go till its practical level, till this details level. Sir, please cover all topics. We'll try. Agreed? Now, next we'll go into the different kinds of the vector integration. Now, I would ask one thing. What does that mean by the line integration? Many of the students would not be able to explain what does it mean by the line integration, why we perform the line integration, and how the line integration is different than the integration which we do in mathematics, which we call it definite integral. No, you would not be able to do that. That is why I am saying I am going to spend around maybe 1.5 hours or maybe 2 hours just on the concept of line integration. Similarly, the same concept goes with the surface integration. We'll see the surface integration as well as closed surface integration. Once we are done with that, that means almost we are done with the integration, we will straight away move it to the differential operators. So the vector have got the different kinds of the differential operator. We'll start with the curl. We'll try to physically understand what the curl of a vector results. Yes, we'll try to understand that. Once we are done with that, we'll move it to the next operator, and that's nothing but the divergence. We'll try to understand if the divergence is applied across or over a certain vector quantity, the scalar quantity comes out. What does actually mean of that scalar quantity? That is what I am saying, my dear friends. I have been there, the teacher of the electromagnetic field theory, so I understand the individual problems over the individual tools. So until and unless you do not go into that detail level, you will not be able to appreciate the individual tools. Once we are done with that, we will try to understand the concept of gradient. Utterly important topic, utterly important tool. Yes, agreed, no? So in vector calculus, you forget about your each and individual doubts or queries. You are from either of the branch, you are thorough with the vector calculus once my vector calculus delivery is over from my side. Yes, and specifically for EE, EC and IN, the practical understanding of the vector calculus is utterly important. Why? Because the electromagnetic theory has got added within electrical as well as instrumentation. So practical understanding of the vector calculus as well as its tools are very important now. And now I have seen even in mechanical and civil also they are asking practical depth problem from the vector calculus. Until and unless you are not well acquainted with its practical aspects, probably you may leave few number of problems. So what I would be doing, I would be taking the different tools, I'll be going into the great detail, and after going into the great detail, I would be taking well-designed previous year questions, and from there I will try to visualize you guys. See, such a well-designed problem it was, whether you could have solved it or not, but you could not recognize what the problem was and how intense that problem was, how conceptual that problem was. Agreed? Once we are done with this, we will move it to the random variable and the random process. At very beginning, we'll try to understand what does it mean by the random process. What does it mean by the random variable? How the random variable is different than the standard variable. Yes, we used to have a functions, no? Within the functions, we used to have the variables, independent variable, dependent variable. First, we'll focus how the independent variable, dependent variable, or in general, standard variable is different than the random variable. Once we are done with that, we will have few of the statistical tools which would be superimposed over the random variable as well as random process. There I would be discussing about mean, which we call it expectation, standard deviation, variance, the so many important tools which we are going to discuss on, and yes, variance. End of the day, what we will see, the distribution of the random values can form any arbitrary values or any arbitrary distribution. But yes, we discuss about few of the important distributions where most of the practical problem do fall. Like in production, in mechanical, the manufacturing of bolt, they used to have little bit defects. The defects used to almost follow the normal distribution. I will try to correlate how they are being correlated. Similarly, if we'll say the temperature, if I am teaching from the Korba, even the temperature within the Korba almost follow a normal distribution. So what I would say, I would take few of the practical problems. I will try to figure it out how the practical problem have made a normal distribution, and from normal distribution we'll figure it out few of the important parameters. End of the day, you will be much thorough with the each and individual things. Each and individual things. Sir, any prerequisites for nothing, my dear friends, nothing. If you are with me, I would say you would be more than comfortable once you're done with the vector calculus. Once we are done with the vector calculus. Agreed? Now, the next thing comes in your mind, sir, which books to be followed? I won't recommend any book to be followed. You just follow my video. You just follow my video. And yes, if you really want to go into the detailed problem approach, you can use our book, because the tremendous amount of problems are being given specifically from the vector calculus as well as random variable and random process. Anyways, before starting today's session or before focusing over the vector calculus, I would like to take the concurrence from each one of you, the people who are present over the live chat. Just wanted to know which branch you are from, that's the first thing, and specifically whether you have wrote the GATE 2021 or not. If you have wrote GATE 2021, you can just write your branch and yes, and if you have not wrote GATE 2021, you can just write your branch and then no. So I would at least will be able to know, okay sir, I am also from EE. Okay, so at least I'll get to know how many students are there and what must be my approach towards this subject. Because once you have the different streams of student, the approach should change for any of the engineering mathematics teacher, and definitely I will follow the same. Instrumentation, first year. Okay, I am from first year, can start. Obviously, my dear friends, obviously you will just love these lectures. EC, yes. Teja, I am EC sir, attempted GATE. EE, no. Okay, no issue at all. So definitely I could figure it out. Most of the students are from EC, EE or instrumentation. So I would do one thing, even I will go into the even great detail, because end of the day you also had to understand the concept of electromagnetic theory, and that too in the great detail. Okay, ME, no issue. So what I would be doing from today onwards, we are going to start the topic called vector calculus. I would suggest to each one of you, have the pen and copy front of you, and whatever the points which I am writing, and in between I would be dictating few of the important phrases or few of the important paragraphs that also you have to write within your copy, because end of the day the copy is the thing which is going to suffice your complete requirement. Why? Because you cannot watch my video again and again for the revision purpose. End of the day, your copy is the whole soul which will supply the demand whenever it is required. So here it's gonna be vector calculus. Vector calculus. Yes, vector calculus. See, whenever the vector calculus comes in our mind, the first thing strikes in our mind, and that's nothing but the coordinate system. My dear friends, leave about the vector calculus, the scalar calculus, everything leave aside. Just focus over the coordinate system. May I know what does it mean by the coordinate system? So my first focus over the vector calculus is gonna be coordinate system. It's a very interesting story over the coordinate system. The first important word which I would like to coordinate system. Coordinate systems. Yes. My dear friends, what does it mean by the coordinate system? And just briefly wanted to ask, what does actually the coordinate system is used for? My dear friends, the coordinate system is used for the uniquely locating a certain point over the 3D space. I repeat, the coordinate systems are used for unique identification or unique location of any point over the 3D space. So you can write over here what the coordinate system does. The coordinate system uniquely locates a point over 3D space. 3D space. Yes, space. 3D space. Agreed? Now the next thing comes in mind, sir. What does that mean by the unique identification of a point over the 3D space? My dear friends, let's take the mosquito is flying somewhere, and let's take for a time being at a moment time t is equals to t1, the mosquito has been positioned around certain this point, Now, uniquely you wanted to identify this point. You cannot just say, sir, the mosquito was there or mosquito was here. Being an engineer, you must be able to quantify the exact location of the mosquito at the moment of time t1. May I know what are those numbers has to be used? And those number would be any arbitrary number, or they must be a certain standard number. Yes, my dear friends, they had to be a certain standard numbers. Why? Because those standard numbers should not change its meaning once it transfers from one point to the another point. Like if I say 1, 2, 3, so whatever the conclusion I get from the 1, 2, 3, the same conclusion you must be getting, and even if the same information has been passed down to the different student, they must also be interpreting the same information from that content. So what does it mean of it? What does it mean of it? Sir, you are... Yes? Agreed, no? So what I am saying, unique location of a point over the 3D space. Okay, sir, that's fine. Now, if you'll go back around 100 years, the different mathematicians had their own coordinate systems. Probably in that moment of time, we had 50 to 60 number of different coordinate systems. Like if you are genius in engineering mathematics, you have come with your own coordinate system. Let's take, we have got your friend, he is also magician in mathematics, he have come with its own coordinate system. So if you'll go 100 years back, there were several kinds of the coordinate system. So may I know how the several number of coordinate systems has been consolidated and has been nulled down to the 3 coordinate system, and that is nothing but the Cartesian coordinate system, cylindrical coordinate system, and spherical coordinate system. There must be a certain basis from which out of 100 number of coordinate systems we could select only 3 number of coordinate system. We had to look into that filtering process, because that filtering process is very important, and all of 3 coordinate systems which on which we would be focusing on, they have got all those properties which could not got with the rest of them. Yes, so that is what the second important point. If you'll go 100 years back, we have plenty amount of coordinate systems. We have got a plenty amount of coordinate systems. Yes, for the time being, let's take the 100 number of coordinate systems we had. The different mathematicians had their own understanding, and they have come across, or they have come with different coordinate systems. 100 of the coordinate systems we had, but we have filtered all of them, and we have been left with only 3 coordinate systems. May I know what? So probably you could have gone through this 3 coordinate system. Let me name them, and they are, first is gonna be the most basic form of coordinate system, and that is nothing but Cartesian coordinate system. Yes. Similarly, the second is gonna be cylindrical coordinate system. And third is gonna be spherical coordinate system. Now, I would wait for a bit and would like to ask from each one of you, what were the advantages with the Cartesian, cylindrical, and spherical coordinate system, such that out of 100 number of coordinate system, only 3 coordinate system got qualified, and now most of the problems are getting solved around these 3 coordinate systems alone. Agreed what I am saying? I wanted to know from each one of you. I want the comment over the comment box. Why we have gone through, or why we have nulled down to only 3 coordinate system out of such a huge number of coordinate system. Definitely this should have a certain upper edge in compare with the rest of them. So can I pinpoint what are the upper edge this 3 coordinate system have? I wanted to know from each one of you. Then only you will understand why these 3 coordinate systems are being useful, and why sometime I go ahead with the cylindrical coordinate system, sometime I go ahead with the spherical coordinate system, and sometime I go ahead with the Cartesian coordinate system. Tell me Tell me, what's the advantage this 3 coordinate system they have? My dear friends, anyways, let me list down those points also. Yes. First thing, anyways, no comment, I have got it so far over the live chat, but still I would be expecting if you guys are having any sort of comment, you can put it over the live chat. The first thing, they are orthogonal coordinate system. They means all three. Anyways, what's the advantage you will be having if all of three are the orthogonal systems or orthogonal coordinate system? My dear friends, once you go into the detailed study of the Cartesian coordinate system, the 3 number gates involved, the first is x, y and z. Similarly, once you go into the cylindrical coordinate system, the 3 number gates involved, that's nothing but the rho, phi and z. And once you go into the detailed study of the spherical coordinate system, you will see the 3 number gates involved, that's nothing but the r, theta and phi. Now, for the time being, if I have taken the unit vector in their respective direction, like in Cartesian coordinate system, in the direction of x, let's take ax cap. In the direction of y, ay cap. In the direction of z, az cap. And one of the most interesting and amusing thing is they all are perpendicular to each other. For the time being, if this axis has been taken as x-axis, so the unit normal in the direction of x-axis is going to be ax cap. For the time being, this has been taken as y-axis, so the unit normal in the direction of y-axis is nothing but the ay cap. And similarly, let's take it has been taken as z-axis, so that the unit normal in the direction of z-axis is nothing but the az cap, and you can see very well they all are maintaining 90 degree. So what's the advantage you will be having? So the advantage what we would be having in future, the 2 of the mathematical operations we are going to perform repeatedly. What are they? First is going to be cross multiplication and the second is going to be dot multiplication. The performing cross multiplication and dot multiplications becomes utterly delicious as well as simple. Why? Because in future you will see the dot product between the unit vector in the direction of ax cap and ay cap is 0. May I know why? Now the people would say, sir, because they are orthogonal. No, my dear friends, orthogonal was the basis on which out of 100 number of coordinate systems, only 3 coordinate systems has been filtered out, and yes, all of the 3 components in the direction of x, y and z, they are 90 degree apart from each other, and hence their dot product has to be 0. That is why in future when we would be performing the dot product, the calculation of the dot products becomes very easy. Like if you have a vector, b vector which contains the component in the direction of ax cap, ay cap, az cap, ax cap, ay cap, az cap, once you perform the dot product, you get to know the dot multiplication between ax with the ay, ax with the az, ay with the ax, ay with the az becomes 0. And one of the most important thing, with the like unit vectors, it simply becomes 1. Agreed? Could you understand what's the advantage you are getting? Yes, what's the advantage you are getting? And this concept goes with all of the remaining unit vectors. Yes, and similarly it is equally valid for ayy cap and similarly azz cap. But so far I have just taken the reference of the Cartesian coordinate system, but the cylindrical as well as spherical coordinate systems are also the orthogonal system. What does it mean of it? That means unit vector in the direction of rho cap, phi cap and z cap, they again are gonna be orthogonal. Anyways, most of students do not even understand what does it mean by the a rho cap, a phi cap, a z cap. Once I would go into the detailed study of the cylindrical coordinate system, I will try to emphasize, you all will have a visualization of the a rho cap, a phi cap, a z cap. Then only you would be able to smash the problems related to the electromagnetic field theory within the electrical, electronics or instrumentation. Yes, my dear friends, what I am saying. So now the same thing goes with the rest of the coordinate system. Even a rho cap dot of a phi cap, even a phi cap dot of az cap, even a rho cap dot of az cap, they all are 0. Yes, agreed, no? Not only that, even the spherical coordinate system is also designed in such a way that all of the unit normals are orthogonal to each other. End of the day, there also you get the same outcome. A r cap dot multiplication with the a theta. Let's take the unit vector in the direction of theta gets dot multiplied with the a phi, and a phi gets dot multiplied with the aj. Simply becomes 0. So what's the advantage we have? The first advantage, they are being an orthogonal system. Their dot multiplication and their cross multiplication becomes utterly simple. Yes. Even if you will take the reference like arrow cap, a phi cap, simply it becomes az cap, and even arrow cap cross of arrow cap simply becomes 0. Anyways, I am not going into the detailed study of the dot product as well as cross product, because it would be an exclusive topic which I would be dealing with in the engineering mathematics. The first advantage with the 3 coordinate system which we have finalized, and that's nothing but they all are the orthogonal coordinate system. That's the first thing. What about the second one? They are interchangeable in nature. What does that mean of it? That means for the time being, if you have taken the reference of Cartesian coordinate system to smash a certain problem, at any moment of time you can change that problem into the cylindrical coordinate system or the spherical coordinate system without losing any information. That means choice is yours. You can approach the same problem in the Cartesian coordinate system or the cylindrical coordinate system or the spherical coordinate system. Even I can give few number of examples. If I will say the electric field intensity because of a line charge, in few of the books the problem has been solved with the help of cylindrical coordinate system, and in few of the books the problem has been solved with the help of Cartesian coordinate system. What does that mean of it? That means it just your choice whether you are using either of the coordinate system. If you choose either of the coordinate system at any moment of time without losing your information, you can jump it to the any coordinate system. Agreed? So what I would say, lossless transformation. Transformation. Lossless transformation. Agreed? Lossless transformation. That means at any moment of time, if you have got a vector A, let's take it's been written in Cartesian coordinate. Similarly, the same vector A is being written in cylindrical coordinate system. Anyways, you need not to worry about rho, phi and z. And similarly, the same vector is being written in a spherical coordinate system. Without losing any sort of information, they can be interchanged at any moment of time. Even I would take few number of practice problems based on this concept. Yes. Agreed, no? Now the next important point, the third important point, the each and individual Cartesian coordinate system have got their own limitations. Like if I will take a few number of examples, like if you have a point charge, the electric field which is emerging out from the point charge is radial in the direction. So that if you really wanted to study the electric field near to the point charge, definitely the spherical coordinate system would have been the better coordinate system to approach with. Similarly, if you have a line charge, so you might have been a little bit idea about the electric field. If you're not, no issue. Our sir is coming with the electromagnetic field theory from tomorrow onwards, so definitely you're going to enjoy that video also. But the electric field, because of a line charge, how used to be the direction of the electric field? It used to be in the direction of arrow cap. So once we discuss the electric field because of a line charge, which coordinate system would help you a lot? Obviously it is gonna be cylindrical coordinate system. And similarly, if I take a next condition, if the charge has been thrown over this surface, and now the electric flux is emerging normally out from this surface, may I know which coordinate system would be the suitable coordinate system? That's nothing but the Cartesian coordinate system. So what I am saying, each and individual coordinate system has got their own advantages. In few of the practical situations, you will see the dealing with the spherical coordinate system would become much easy. Similarly, in few of the practical situation, you will see dealing with the Cartesian as well as cylindrical system would become much simpler. Yes. So what I am saying, their practical usage. their practical usage. Like if I take one example, if you wanted to study the electric field intensities around a line charge, so probably you could have used the cylindrical coordinate system, Similarly, if you wanted to analyze the electric field because of a point charge, probably you could have gone with the spherical coordinate system. Anyways, in future I would be taking few number of examples from the mechanical as well as civil, so you guys should not have any sort of confusion that it would be planned only for the electrical and electronics. No, even I would be taking few practical problems from the mechanical, specifically from the heat transfer, and similarly few of the problems from the civil, specifically from the load diagram. Yes, so you will have a fair understanding about the vector calculus and how it is being used practically within your syllabus. Yes, and now if you have surface charge, if you have a surface charge distribution, here the Cartesian coordinate system used to be much handy to deal with. Anyways, keep aside each and everything. I will try to smash the Cartesian coordinate system in today's video, and many of us would say, sir, we know a bit about the Cartesian coordinate system, so you can skip the Cartesian coordinate system, but still I would teach the Cartesian coordinate system, and end of the day I would take few of the class works, and I would like to ask from each one of you, with the help of those questions, how far you could understand the concept of the Cartesian coordinate system. And I understand 50% student would not be able to reply it well, because I have designed few of the well-designed problem. Yes, so what I would do at very beginning, let me bifurcate into the two parts. The first thing goes like, yeah. The focus is on Cartesian coordinate system, so you can write the heading is nothing but the Cartesian coordinate system. The heading is gonna be Cartesian coordinate system. Coordinate system. The heading is going to be Cartesian coordinate system. Yes, the heading is going to be Cartesian coordinate system. Now, within the Cartesian coordinate system, the first important point which I would like to write, and that is nothing but unique identification of the point, unique location. My dear friends, all of three different kinds of the coordinate system uses the different numerologies to uniquely identify the location over the 3D space. Like the spherical coordinate system uses rho phi z, spherical coordinate system uses r theta phi, cylindrical coordinate system uses rho phi z. Specifically the Cartesian coordinate system uses x, y and z. Agreed? Uses x, y and z. Yes, x, y and z. The next thing which comes in a mind, what about the natures of x, y and z? Obviously, x, y and z, all of three numbers should always be a real number. That is the first thing. Should always be a real number. You can't say, sir, I have got a x which is equal to of 3 plus j. No, that's not at all. Similarly, if we'll talk about the range of x, y and z, may I know what would be the range of x, y and z? Theoretically, it can start from minus infinity and can go till plus infinity. Yes. Why the word theoretically? Because infinity is not well defined. That is why we used to assume it is starting from minus infinity and going till plus infinity in the open interval. That means minus infinity and plus infinity is well excluded. Similarly, if we'll talk about y, the range is in between minus infinity to plus infinity. Similarly, if we'll talk about the z, it's gonna be minus infinity to plus infinity. Yes. Now let me figure it out. What does actual mean of x, y and z? And once you're done with that, you really start enjoying the concept of the vector calculus. See what I'm going to do. At very beginning, let me draw the Cartesian coordinate system over this digital board. let me draw the Cartesian coordinate system over this digital board. So let's take, here goes my z-axis, here goes my y-axis, and x-axis is towards outside this board. Outside this board. Anyways, I can draw in this way. It is coming out. It is coming out. Yes. It is coming out vertically towards your side. Towards your side. Avinash Karmakar, I am sure about it, my dear friend. Once you will go, or once you will reach to the actual crux of the vector calculus, where we deal with the surface integration, vector integration, line integration, divergence curl, you will really start feeling the actual meaning of those tools. Yes. So what I would be doing over here, let's take, this is what my x-axis, this is what my y-axis, this is what my z-axis, this is what my z-axis. Let's take in 3D space what it is, you assume in this way, this is, just understand this way. You can mark a line over here, and that is nothing but the z-axis. The axis which is coming outside from this plane is nothing but the x-axis, and similarly traveling towards right hand side is nothing but the y-axis. Now tell me one thing. If I wanted to locate a point uniquely over the Cartesian coordinate, how will I locate this? Just focus over this 3D coordinate system, and similarly just focus over the practical aspects of this problem. What I would do, I would just drop this point. This point will fall over the xy plane. Agreed what I am saying? Let's take, if you have a point and you wanted to uniquely locate this point, what you would do, you would drop this point over the xy plane. Agreed? Now what you would do, you would calculate its vertical distance from the y-axis, and similarly you will calculate its vertical distance from x-axis. Yes. May I know what are the values? Yes. So here, this is the movement towards the y-axis, and hence the displacement is gonna be the component of y. Agreed? Now, as it is been moving towards right hand side, the worth would be taken positive. Similarly, if I'll talk about this movement of this displacement has been taken place in the direction of positive x. Although it is looking inclined, but it's just coming outside. You can see like this. You had a point, you just drop it down, it was dropped over the xy plane, and now you are measuring the distance from the y-axis, and similarly you are measuring the distance from the x-axis. May I know what's going to be this measurement? This measurement is from x-axis towards the y direction. I would just be writing it y dash. Yes. Similarly, this is towards the x-axis. Let's take the displacement is x dash, so simply I would be writing it x dash. Similarly, the point from where it was dropped down over the xy plane, let's take the displacement was z in the direction of z direction. Simply I have taken this as z dash. Now you can easily mark the point. The point is simply going to be x prime, y prime, and z prime. X prime, y prime, and z prime. Agreed, my dear friends? So here is simply going to be x prime, y prime, and z prime. Agreed. Now I would like to ask from each one of you. One important thing. Like in terms of the different varieties of sign, in terms of different varieties in sign, plus, minus, plus, minus. Yes. You had the 4 different options within the 2D coordinate system, and which was quadrant system. First quadrant, second quadrant, third quadrant, fourth quadrant. Now in 3D space or 3D Cartesian coordinate system, how many variations you can have in terms of sign? Now you can have the 8 number of variations. How? All are 0 or all are minus, then minus plus, then minus plus minus, put together the 8 number of variations you will have. Would you be able to figure it out? Would you be able to figure it out? What does it mean by the each and individual signs, and which particular portion would come under which particular sign? Which particular sign? Yes. So what I would say, let me just a minute, let me just bifurcate in the two parts. So in terms of the varieties of the sign of x, y, z, it can be bifurcated like minus minus minus, minus minus plus, minus plus minus, minus plus plus, then plus minus minus, plus minus plus, plus plus minus, and plus plus plus. So as we had in 2D Cartesian coordinate system, quadrant system, but here we would have octant system, octant system, octant system, octant system, octant system. So just wanted to, just a minute, let me see the different comments which have come so far. Yes, tell me. Now, if you really wanted to figure it out, the complete 3D space in the 8 different segments, like we did in 2D plane in 4 different segments, there it was quadrant, here it is octant, here it is octant. I wanted to know one thing. Now, if you have kept a point somewhere here, it would come under which octant? Would it come under minus minus minus, minus plus, minus minus plus, minus plus minus, plus minus minus, plus plus plus? Tell me. This understanding is utterly important just to understand the Cartesian coordinate system into the much deeper way. Tell me, if a mosquito is flying somewhere here, it is flying in which quadrant system, in which octant system? Whether it is in minus minus minus, minus minus plus, minus plus minus, minus plus plus, or it is at plus plus plus. I wanted to know from each one of you from the comment. My dear friends, see what's happening over here. If you're talking about a mosquito which is somewhere here, to locate this mosquito, you are coming out from this plane. Which plane it is? It is nothing but the yz plane. You are coming towards the positive value of x. What does that mean of it? Definitely, mosquito is being placed towards the positive value of x, as it is being towards a higher value of x in compare with the x is equals to 0. That's the first thing. Once we are done with this, now we will focus over the y. My dear friends, y was 0 over here, and as you move towards right hand side, the y increases in a positive sense, and similarly towards the left hand side it decreases in the negative sense. So what is happening over here? Now if you have a mosquito over here, to locate this mosquito, you had to take the reference of which plane? Could you able to see what I am saying? You had to take the reference of which plane? You had to take the reference of xz plane. I don't know how far you are able to understand xz plane, and precisely speaking y is equals to 0 plane. And now as the mosquito is being kept somewhere here, and you are taking the reference of y is equals to 0 plane or the xz plane, and to reach this point you had to move forward towards the positive value of y. What does it mean of it? Even the y is also positive. Agreed? What about z? Now what you would see, now you will take the another plane. Which plane it is? That is nothing but the xy plane, and precisely speaking z is equals to 0 plane. Now the mosquito is somewhere here, and this is nothing but your z is equals to 0 plane, and you are coming upwards to fetch this point. What does it mean of it? That means even the z is also positive. Could you understand what I am saying? This point, taking the reference of this plane, which plane it is for the time being, you can say this is a yz plane. You are coming out, or you are coming towards the positive value of x. X is positive. Similarly, this mosquito was towards the right hand side, taking the reference of xz plane. Again the y is positive, and it was towards the upside of z is equals to 0 plane, and hence z is also positive. So just wanted to figure it out, each and individual thing. So first question which I have taken, there the x is positive, y is positive, and even z is also positive. Yes, I would like to ask one problem from each one of you. If one point or mosquito has been placed just behind this digital board, what would be the value of octant system? Which are the values would be positive, which are the values would be negative? I would like to take the input from each one of you. I would like to take the input from each one of you. What I have done, only one change has been made. So far the mosquito was flying somewhere here. Now the location of the mosquito has been flipped towards the inside, So tell me, what would be the polarities of x, y and z? I wanted to know over the digital board. My dear friends, minus and plus you have written. You are dealing with the three different numbers, so you should write the polarity of all three numbers, x, y and z. Rupesh Govda, what I am saying, you have been dealing with the 3D space and that to Cartesian coordinate system. It contains the three numbers. So you should say the polarity of all three numbers. You're just sticking to two numbers, which is not correct. So the answer have started coming, minus, 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 plus, plus, then minus, plus, plus. Tell me what would be the best most answer. My dear friend, now this point has been flipped inside. Now again you had to take the reference of plane. Which plane it is? It is a YZ plane, and you had to go inside, or that means you are keep going towards a negative value of x. That's the first thing. And similarly, again, if you will be talking about the value of y, my dear friend, again you will be taking the reference of y is equals to 0 plane or xz plane. Is still that point, although it is at towards behind side, but still you are moving towards the positive value of y. What does that mean of it? The y is positive. Agreed? And similarly, what I am saying, if you take the reference of the point which is backward side of this digital board, is still you are going towards upside, taking the reference of z is equals to 0 plane or xy plane. The z is also positive. My dear friend, y positive, z positive, and yes, this point has been flipped inside. That means you are going towards a negative value of x. The x is gonna be negative. Could you understand or not? Tell me. Minus, then plus, then plus. I know many of us would not be able to figure it out. That is why I say in future the curl, gradient, line integration, surface integration, and most important net flux coming out becomes a tell mark to all of us. Could you understand till this point? Just wanted to know, till this point probably each one of us could have got little bit idea about the octant system which we deal within the Cartesian coordinate system of 3D space. Yes? No. Tell me when this situation would arise. Although I was giving a location and I wanted to know which are the polarities would be positive and negative. Now I have given the polarities of all three numbers x, y and z, and just wanted to know where this point would get located. Yes. Tell me where this point would get located. If x is positive, you have to come out. If y is positive, you have to come this side. If z is negative, you have to go down. Taking the reference of z is equals to 0. So you can say very well, this was my mosquito. The mosquito has to go down. First it has come to the z is equals to 0. Now it has to go downside. Yes. No. Could you understand what I am saying? The z is negative. What does it mean of it? So far, the movement towards upside was taken, the variation in z. If I was going towards the upside, the z was taken, keep on increasing towards positive side. And if I go downside, then definitely the z becomes negative. Agreed what I am saying? So plus, plus, minus, the same mosquito has been displaced towards downside and it has been kept towards the downside. Yes? No? Now, if I take the fourth condition, what I have done, here we have got a mosquito. Now this mosquito has been shifted towards that room, nearby room, just right hand side. Tell me what would be the coordinate values in terms of their signs. I am not talking about their values, yes, in terms of sign. That means this mosquito is keep flying and it has gone into the different room. Probably I would not be able to explain each and everything over the digital board because it has to be keep rotated, but still you guys would have the clear cut idea what exactly I wanted to communicate. Tell me what would be the value of x, what would be the value of y, what would be the value of z. Tell me what would be the value of z. Now the student have started getting the answers. Yes. My dear friends, if the mosquito goes towards that side, is still to fetch that point you have to come outside, the value of x is positive. Similarly, to fetch that point you have to come upside, again the value of z is positive. But from y is equals to 0 plane, you are not traveling towards this side where the y is positive, you are traveling towards back side the y is negative. So simply it's gonna be 1 minus, sorry, plus minus plus, plus minus plus, yes, plus minus plus. Now here goes the fifth point. What I have done, a new room has been created just behind this digital board. That calculation is already been made, and now I have taken another room just down to that. That means we had a room just behind this digital board, and now I have digged up another room which is just lower than the room which is just behind of this digital board. May I know what would be the coordinate polarities at that point? What would be the polarities at that point? Tell me what I am saying here. Initially it was here, now it was gone behind, and now it has gone down. Backside alone. Tell me what would be the worth of x, what would be the worth of y, what would be the worth of z? My dear friends, as the mosquito is behind this board, what does that mean of it? That means to fetch that point you had to go towards the negative value of x. Obviously the x would become negative. Once you are done with this, definitely you have to talk about the y. This is nothing but the y is equals to 0 plane, and still you are moving towards the positive value of y. The y would be positive, and if you talk about the z, my dear friend, if you take the reference of z is equals to 0 plane, if you move upward, the value of z becomes more and more positive. If you go downwards, the value of z becomes more and more negative. So obviously it's gonna be minus plus minus, minus plus minus. Yes, minus plus minus. Agreed? So what I wanted to communicate is specifically in Cartesian coordinate system, uniquely locating a certain point requires the 3 numbers, and 3 numbers are x, y and z. That's the first thing. All of 3 numbers are always going to be a real number. You cannot use the complex or pure imaginary number. That's the second thing. And now if you talk about their ranges, the ranges starts from minus infinity and goes till plus infinity. Why? You can see very well, if you are keep moving towards this direction, the y is keep increasing, and you can go far away, and you can go in hypothetically at very far away from taking the reference of y plane. So definitely it becomes infinity. So the range of y goes till plus infinity, and even it can move towards the left hand side, and it can keep go towards the left hand side, and that too high distinct. That means again the y becomes minus infinity. Not only that, even now the mosquito can be keep flying towards the positive value of z, and hypothetically it can go till plus infinity, and similarly it can keep going down towards the negative value of z, and hypothetically speaking it can go till minus infinity, and hence the ranges of x, y and z is being taken as minus infinity till plus infinity, minus infinity till plus infinity, minus infinity till plus infinity. Yes. Now the next thing, I know many of the students would have one doubt over here, what it is. My dear friends, if you go upward, the z increases. If you go downwards, the z decreases. But neither you have gone up, neither you have gone down. The value of z is precisely 0. That's the first thing. Similarly, if you go towards right hand side, the y increases in the positive sense, and similarly if you go towards the left hand side, the negative value increases. But here, if you have been kept over a certain this fixed point, neither you have gone towards right hand side, neither you have come towards left hand side, the value of y is precisely 0. Okay. And similarly, if we'll talk about the value of x, neither you have come out, neither you have come down, the value of x is also 0. So in future, 0, 0, would be called as the origin of your 3D coordinate system, which is simply written as capital O. Right? So in future, whenever I refer origin, basically I have been sitting over the no displacement case, either in direction of x, either in direction of y, either in direction of z. Yes, either in direction of z. Agreed. Now the next thing comes in mind, which plane it is. Yes, few of the important point now I am going to discuss, and the problem do come from this segment repeatedly. What I am saying, which plane it is, the plane on which I am drawing or writing the digital board, which plane it is. I wanted to ask from each one of you, which plane it is. My dear friend, many of us would say, sir, as such there is no change in the component of x-axis over this plane, and hence it would be called as a yz plane. Whether it is a appropriate statement, so far no answer I have got it, but anyways, no, it is not an appropriate statement. Why? Because if I'll keep this digital board and will start moving towards your side or towards the side of camera, what would happen? Now the digital board have come somewhere here. You can see like this. Yes, the digital board have come like this. And still once you'll move here and there is no change in x. So the yz plane which you had earlier, the yz plane which you have now, whether they are same or whether they are different, they are different. So rather calling it yz plane, I must be calling it x is equals to of constant plane over this digital board. Either you are here, either you are here, either you are here, either you are here, either you are here. One thing is fixed. What it is? Neither you have moved towards outside, neither you have moved towards backside. Y and z is changing, there is no problem as such, but the value of x is being kept constant at 0. So should I be calling it yz plane? Yes, you can call it yz plane, but if that is yz plane, even this is also yz plane, then what's the difference between this yz plane and this yz plane? The value of x. What I am saying, the value of x. Here the value of x is 0, and for the time being, if you have shifted this digital board, let's take 1 meter apart from this location. Now here the value of x becomes 1. The value of x becomes 1. Agreed what I am saying? Agreed what I am saying? So in future, rather calling it yz plane, you had the problem, no? This is also yz plane, and even this complete digital board has been shifted towards outside, that is also yz plane, and if it has been switched towards the downside, still it is a yz plane. So rather calling it yz plane, I would be calling x is equals to of constant plane from here onwards. And many of these students used to have one doubt, sir, how x is equals to c is gonna be a plane? My dear friend, it's a plane alone. Why? Because you can see very well, as far as this board is concerned, the y and z can take its own value from minus infinity to plus infinity, whereas the value of x has been fixed to c. That means the x cannot change. What does it mean of it? That is nothing but a yz plane. Yes. Similarly, if I say xz plane, can you figure it out? What does it mean by the xz plane? There is a variation in x, there is a variation in z. So obviously this is gonna be the xz plane. What I am saying, this is gonna be xz plane. Yes. Now, if you are bringing this towards the right side and left side, still it is a xz plane. Why? Because there is a change in x, and similarly there is a change in z axis, whereas the value of y is kept constant. But still, to just make a proper distinction between this xz plane and between this xz plane, I must be giving the appropriate name. What it is? You can see very well, when this was a xz plane, the value of y was fixed. Let's take the y was kept over 0, and similarly if it has got shifted by 1 meter, now the value of y became 1. So the xz plane should also be called as a y is equals to of constant plane, depending on the different values. The c can take its own value, obviously has to be real, could be positive as well as negative. Now here goes xy plane. Could you see the xy plane? Yes, sir. This is nothing but the xy plane. My dear friends, this is nothing but the xy plane. Now what is happening over here? If this xy plane is lifted a bit, still it is a xy plane because there is no change in z as such, and similarly if it is gone down, still it is a xy plane. So telling this plane as a xy plane is not mathematically that correct or that accurate. For making it more accurate, what I would say, although it is a xy plane, but I would say, tell me what's the worth of z. Then it is going to say the worth of z is simply 0. So I would say this plane is simply going to be z is equals to 0 plane. Sometimes z is equals to 1, sometimes z is equals to 2, sometimes z is equals to minus 1, minus 2. End of the day, xy plane would be called as z is equals to of constant plane. So many of the times the student do have one doubt. Whenever they come across x is equals to 0. If the plane is not being written, what they would say, sir, x is equals to constant, that means the value of y is equals to 0, the value of z is equals to 0. Who said the value of y and z is 0? We have just said the value of x is a constant value, it can't change. What does that mean by the y and z? The y and z can take its own value within their range, and that is nothing but minus infinity to plus infinity, minus infinity to plus infinity, minus infinity to plus infinity. Agreed? So now just wanted to ask, what does it mean by, x is equals to 0? X is equals to 0 is going to be a infinite yz plane. What I am saying, why infinite? X is being kept 0, no? So obviously it has to be over the digital board. Nothing has been given regarding the y as well as z. That means the y can take its own values from plus infinity to minus infinity. Z can take its own value to plus z to the minus z plus infinity to the minus infinity. Put together, it would be an infinite plane. Infinite plane. Which type of infinite plane? Obviously this infinite plane is being placed over the yz, but for the better specification I can say it is at x is equals to 0. Is at x is equals to 0. So if I say x is equals to 0, it's an infinite plane. Infinite which plane? Infinite yz plane kept at x is equals to 0. Kept at x is equals to 0. Yes. Similarly, if I take y is equals to 0 plane, what it is? This is the y is equals to 0 plane. So now the z can take its own values, and similarly x can take its own values. Again, it's going to be infinite xz plane, and yes, the y has been fixed to 0. Y has been fixed to 0. Similarly, you can have z is equals to 0. Z is equals to 0. It's going to be infinite xy plane, where z has been fixed to 0. Z has been fixed to 0. So I would suggest to each one of you, just have a look what I wanted to communicate in this class, because I am not going to take the class more than 1 hour, because so many subjects are running in parallel. Probably from tomorrow onwards EMFT is going to come, Diptanshu sir is also coming along with its subject. So we are not going to take more than 1 hour, and I would request to each one of you, at very beginning probably you might be finding this lecture bit boring, but once I will go into the core detail of divergence, curl and gradient, I had experience, all of the students used to be more than happy, and really they try to understand, or they start understanding the basic concept of the vector calculus and their tools. So anyways, for today's class, that is all. We'll meet with the next class probably tomorrow, and from tomorrow onwards we'll fix the schedule, and from tomorrow onwards we would be engaging the class at the same slot. Okay, then we'll meet tomorrow. If you guys are having any sort of doubt, you can put it over the live chat, and I'll try to reply those doubts. You can put your doubts over the live chat. Tell me any sort of doubt you guys are having, any type of doubt you guys are having. Any doubt? Thanks, sir. Thank you, dear. Thank you, Sachin Nayak. Probably no doubt we are having at least till this moment of time. So we'll come with the remaining part of the vector calculus tomorrow. Okay then, bye bye. Take care. Good night.